All right, page 396, Chapter 10, Lesson 3, Renewable Energy Resources. So, we're on the last couple weeks of school, and guess what? Challenge! I am not going to write it down for you. I'm going to help you, but you're going to have to figure it out. So, remember to write your name, the class number, and the date. Remember to put Chapter 10, Lesson 3, Renewable Energy Resources, in the same format we've been doing. Page 396, Renewable Energy Resources. Main idea: because fossil fuels are non-renewable and supplies are limited, people are developing ways to use renewable energy resources. These resources include solar energy, wind, biomass, and geothermal energy. Okay, so vocabulary: biomass, page 402. Go to that page. Biomass. Each year, many tons of once living matter, or biomass, go to waste. Okay, so living matter. Biomass, living matter. All right, let's go back. Oh boy, this is a long chapter. Hydroelectric energy, page 399. Electric energy generated from moving water is called hydroelectric energy. So, hydroelectric energy generated from moving water. A good example would be a dam. Geothermal energy, page 401. Okay, let's go to 401. Recall the Earth is hot inside. Thermal energy from Earth's interior is called geothermal energy. So geothermal energy, energy from Earth's interior. And then here's an example of what happens. You use steam originating from inside the Earth because of like plumes of magma, and that steam spins a turbine to generate electricity. Remember in previous chapters, you could use things like coal or natural gas to boil water to create steam. Well, in this case, the steam is just coming straight out of the Earth. All right, nuclear fission, page 400, nuclear fission. So, in a nuclear power plant, nuclei of uranium or plutonium are split in a controlled process called nuclear fission. So nuclear fission, controlled process, ZOOP, how could we say it? Nuclear material split. Right, so uranium and plutonium are nuclear materials. The word materials not here, but you could use that word. Okay, renewable resource is on 396. Renewable resources such as the sun, wind, and moving water can be used day after day without running out. So renewable resources used without running out. Okay, solar energy, 397. The sun supplies solar energy, an inexhaustible energy source. Solar energy, energy from sun, and you could even use the word inexhaustible. It cannot be exhausted, it cannot run out. The sun's going to last millions, if not billions of years, far longer than any of our lifetimes. Okay, the first section, the importance of renewable energy. Imagine a world without any energy resources. Homes, schools, and businesses would have no electricity. Ships, planes, and trains could not transport goods, and people could travel no faster than horses could carry them. In many ways, people would live as they did in the early 1800s. So, a world without energy, like the 1800s. As you have learned, fossil fuels fill most of society's energy needs, but at the current rate of use, these non-renewable resources will run out someday. So, non-renewable will run out someday. What will people do without fossil fuels? One solution involves preparing for the future by finding and developing renewable sources of energy. So, find and develop renewable sources. Renewable resources such as the sun, wind, and moving water can be used day after day without running out. Renewable resources also do not pollute the atmosphere as fossil fuels do. So, renewable do not pollute. However, there are disadvantages associated with any renewable energy source. Some are limited to certain areas, while others require expensive technology. Okay, so disadvantages, limited, expensive. Regardless, many renewable resources contribute to the energy supply today, and they hold the promise of contributing more in the future. So, promising. Okay, solar PV cells were used to run this Mars rover as it explored Mars. PV stands for photovoltaic. That's the same kind of thing that's on top of many people's houses these days. Okay, a new section, solar energy. The sun supplies solar energy, an inexhaustible energy source. So underneath that section, inexhaustible. This means people can never use it up. It is also non-polluting. So, non-polluting. However, harnessing solar energy can be expensive. Oh hey, that's what we just talked about down there. The diagram below shows one way to capture and use solar energy. In this case, solar energy is used to heat water for a house. So, let's see. One way, heat water. Simple versions of solar heaters were common in the late 1800s and early 1900s. People stopped using them when inexpensive fossil fuels became available. Now, solar heaters are becoming popular again, especially in sunny climates. So, were common in 1800s, stopped using fossil fuels, now becoming popular again. Solar energy is also used to make electricity in solar power plants. So, can make electricity. Mirrors reflect the sun's rays onto a central collector. The heat boils water or another liquid, generating steam that turns turbines. Ah, okay, so this is a special kind. Mirrors reflect rays, boil water, steam turns turbines. A solar plant in the Mojave Desert provides power to 350,000 homes. Okay, so this one that they're talking about over here is like a solar collector. The sun literally warms up the water inside these tubes. Okay, the one that they're talking about here is where the sun's rays heat up the water and turn it to steam. Kind of like what's going on with the geothermal energy. Or kind of like that machine that went back when we were talking about machines and how you could use fossil fuels to boil water. Okay, now, photovoltaic cells. That's like these ones, or the ones that are on the houses to generate electricity. Photovoltaic cells, or PV cells, collect light and change it directly into electricity. So, photovoltaic, parentheses, PV, close the parentheses, light directly into electricity. When light hits the cells, electrons are knocked loose from atoms. The loose electrons are channeled into an electric current. Today, PV cells are used to provide electricity for calculators, home appliances, and even spacecraft. And this book being like, 10, 15 years old, there's a lot more uses now. These panels on top of the houses are getting so good, you can power an entire home and have leftover electricity. You can even charge cars now. Okay, solar collector. Energy from the sun heats water inside the solar collector. The hot water then goes to the heat exchanger. Okay, so the sun hits this panel with all these tubes full. The hot water comes down here and can be used throughout the house. And then cold water can be taken in from a water supply or a well or something like that. Heat exchanger. Piped water is pumped into the heat exchanger and heated by hot water from the solar collector. Okay, how can energy from the sun be collected and used? So, energy from the sun can be collected and used at least 3 ways. One way is to directly heat water that gets used in the home. Another way is to heat the water and turn it into steam to turn turbines to generate electricity. And a third way is photovoltaic cells, or PV cells, that cause electrons to be knocked loose and run through the wires like an electrical current. Okay, wind power. People have built and used windmills for hundreds of years. The first windmills were used to grind grain or pump water. As the wind turned the blades or sails, a series of gears would turn to provide power. Okay, so the wind causes a turbine to turn, which then turns this shaft, and back in the day, it would turn like a big stone wheel that you could grind grain with, or it would turn a pump. It would pump up and down to pump water out of a well. As the wind turned the blades or sails, a series of gears would turn to provide power. Okay, so windmills, turned blades, gears provide power. Windmills, turned blades, gears provide power. Thanks to improved technology, wind power is now a promising source of electricity. In the wind turbines shown below, wind is used to spin the blades. Just as in other power plants, a generator converts the mechanical energy of the spinning turbine into electrical energy. Okay, so as long as those fans are spinning, this little motor is spinning, and that is generating electricity. Okay, so let's see. Improved technology, turbines, generator. The amount of energy depends both on the size of the turbine and the wind speed. So depends on size and wind speed. In some countries, wind power is very common. In Denmark, for instance, wind energy provides more than 20% of the country's power. Areas with dozens of wind turbines are called wind farms. The 3 largest wind farms in California make enough electricity to power a city the size of San Francisco. Wind energy does have some drawbacks, however. Wind turbines work best where steady winds blow most of the time. Wind farms also take up a lot of space and they're noisy. Okay, so let's see. Drawbacks. Need steady winds. Take up space. Noisy. Many wind farms today are in desert lands or hilly regions that otherwise would stand empty. Winds blow because the sun heats Earth unevenly. For this reason, the source of wind power is solar energy. Okay, so if you remember all the way back to what we learned about weather, the sun powers the wind powers these turbines. So in reality, these wind turbines are getting their power ultimately from the sun. Okay, a typical wind turbine can be as tall as a 20-story building. It has 3 blades that span 60 meters or longer. Wow, that's huge. And here's a way to know that, right? Look at this picture. There is a semi-truck. And there's how big the wind turbine is. And I can actually tell from this picture because I've driven by these. These wind turbines are in the hills between the Central Valley and San Francisco. As you drive through the hills, you can see this wind farm. Energy from moving water. New section title. Make sure you write that. Like wind, moving water has been used as an energy source for hundreds of years. The Romans built large water wheels on rivers. Right? So instead of a fan blade spinning from the wind, think of a water wheel where the water kind of like sits in a little bucket and the gravity pulls it down and it's constantly spinning. The moving water turned to the wheel. The wheel turned gears to grind the grain. Okay, so let's see. Moving water, water wheels on rivers, turned gears. Electric energy generated from moving water is called hydroelectric energy. To build a hydroelectric power plant, usually the first step is to build a dam on a steep section of a river. Okay, so hydroelectric energy, dam, power plant. Water is stored behind the dam in a reservoir. Near the bottom of the dam, water runs through tunnels to turbines, setting them spinning. The energy from the spinning turbines is converted into electricity. Okay, over the past 100 years, many large hydroelectric power plants have been built in the United States. About 15% of California's electricity comes from such plants. Okay, so about 15%, capital C, capital A, electricity. Hydroelectric plants produce energy without polluting the air. Okay, so no air pollution. They also rely on the water cycle, a free energy source. Okay, rely on water cycle. Although here in California, that's kind of a tough thing because we go through droughts, right? But they can damage river ecosystems. Damage river ecosystems. Large dams and reservoirs change the flow of the river and can harm fish and other animals. For example, some fish, such as salmon, migrate upstream to spawn. A series of dams can interrupt the migration, so some dams include fish ladders, which allow the fish to swim upstream at an angle. Okay, so what they're saying is like you would have all these dams and gates and stuff to let the water flow to spin turbines, but off to the side, there'd be like a little series of levels of water going up so that the salmon and fish can still go over there and swim upriver. The energy of moving water in ocean tides can also be harnessed. Can also harness ocean tides. Can also harness ocean tides. During high tide, water can be trapped behind a dam. Then when the tide goes out and the water recedes into the ocean, the water passes over turbines, just as in river dams. Tidal power plants work best where the difference between high tide and low tide is great. So, tidal power plants, high tide versus low tide. The Annapolis Tidal Generating Station uses turbines to generate electricity. Right? So we've learned about the tides, how the water comes in and out. The water level rises, and then when the water goes out, it flows over turbines, similar to a dam, spins them and generates electricity. How can moving water be a source of electricity? Okay, so we learned about spinning turbines to generate electricity. They could damage ecosystems, so you have to build like little, what did they call them? Fish ladders? Yeah, fish ladders. And then you can also use the tides. Okay, next page, next section, nuclear energy. The nucleus of a uranium atom can break apart, radiating energy in the process. For this reason, uranium and similar elements are said to be radioactive. Okay, so atom break apart, radioactive. In a nuclear power plant, nuclei of uranium or plutonium are split in a controlled process called nuclear fission. This process releases vast amounts of energy. The fission of 1 kilogram or 2 pounds of uranium produces more energy than burning 3 million kilograms or 6 million pounds of coal. Wow. Okay. So let's put 2 pounds uranium, more energy than 6 million pounds coal. 2 pounds uranium, more energy than 6 million pounds coal. At a nuclear power plant, bundles of rods containing uranium are placed in a thick-walled vessel called a reactor. The energy released from fission is used to boil water, producing steam. So, boils water, produces steam. The steam spins turbines. When the water cools down, they pump it back through, and they keep that cycle going. Okay, so let's see. Energy released boils water, steam turns turbines. Energy released, boil water, steam turns turbines. Nuclear power plants offer a clean, quiet way to generate electricity. They do not add soot or carbon dioxide to the atmosphere as burning coal or other fossil fuels. So clean, quiet. However, nuclear power presents risks and drawbacks. The worst risk is the accidental release of radioactive material. In the past 40 years, 2 terrible accidents have occurred at the world's nuclear power plants. A more common problem comes from nuclear waste. Such waste may stay radioactive for thousands of years. Scientists are studying ways to reuse this waste. This book was written before Fukushima in Japan, so there's another example of a tsunami destroyed a nuclear power plant and released a bunch of radioactive material out into the surrounding areas. So, terrible accidents possible, right? Big accidents. There's a note to take. And then nuclear waste. Nuclear waste is a huge problem because it lasts for a very long time, and we don't know what to do with it. Okay, the reactors in this California nuclear power plant are located in the domed buildings. And if you ever go down to San Diego or you drive down that way to go to Mexico, there is a nuclear power plant along the side of Interstate 5 down near San Diego, the San Onofre nuclear power plant. Geothermal energy, a new section, geothermal energy. Recall that Earth is hot inside. Thermal energy from Earth's interior is called geothermal energy. The word stem geo means Earth, and thermal refers to heat. How does geothermal energy work? In some places, magma from Earth's interior is close to underground pools of water. If the water boils, the steam may rise through rocks to the surface. Hey, that kind of sounds like the geysers. So, Earth's interior hot, water boils, steam. And we already know where this is going. Steam can cause turbines to spin and generate electricity. Okay, let's see. Or it may rise through a shaft that people drill. The heated water can be used to heat swimming pools and buildings. The heated water can also be used to produce electricity. In geothermal power plants, steam or hot water is carried through underground pipes. The steam turns turbines that turn generators. The water is sent back down through the pipes to be heated again. Geothermal heat pumps can be used to heat individual homes. Loops of pipes are filled with water and antifreeze, then buried underground. During winter, the water carries heat from the ground into the house. During summer, heat from the house is returned to the cooler ground. Geothermal energy is a free source of energy that will not run out. Okay, so let's go back to this, what they mean. What they mean in the winter is the heat from inside the earth gets brought up to the house. But in the winter, the heat from the house gets put back into the ground as you pump that water down into the ground. Okay, so geothermal heat pump, pipes underground. Let's see. Heat from ground to house. And then you can say, or heat from house to ground. All right, geothermal energy is a free source of energy that will not run out. However, geothermal power plants are best suited to hotspots, places where molten rock from Earth's interior can heat the surface. So this goes back to that idea of them being very limited. Remember we said limited. So let's see. Best suited to hotspots. There are very specific places that you could build a geothermal plant or get geothermal energy from, so you're very limited on where you can do it. Okay, main idea. What is geothermal energy and how is it used? Well, geothermal energy is energy from inside the earth because of magma hotspots. You can use it to generate steam and spin turbines for electricity, or you can use it to directly heat something like a house or a pool. All right. Oh man, this is a long chapter. Okay, biomass. Each year, many tons of once living matter or biomass go to waste. Biomass includes unused plant parts from farms, sawdust and bark from lumber mills, food scraps, and animal wastes. Wood is also a form of biomass. So let's say under that section, let's put E period, G period, for example, plant parts, sawdust, food scraps, animal waste. Because biomass comes from living matter, it contains stored solar energy, just as fossil fuels do. However, the energy in biomass is much less concentrated than in fossil fuels. New technologies are needed to make biomass a cost-efficient energy source. So it sounds like it's expensive. Okay, so we're going to use the word expensive. Biomass can be burned in a power plant to produce electricity. Another use is to allow biomass to decay on farms or in landfills. As it decays, it produces methane gas, a useful fuel. Okay, so can be burned or decay. Unwanted parts of corn plants can be used to make ethanol, a type of alcohol. Ethanol also can be burned as fuel. So corn can make ethanol. Corn can make ethanol. When biomass burns, it causes much less air pollution than fossil fuels. Using biomass for energy also keeps it from taking space in landfills. Landfills are expensive to maintain and take up space that could be put to other uses. Okay, so less air pollution, less landfill. Yet another use for biomass is composting. Place grass clippings, fruit rinds, potato peels, and even unwanted cotton fabric into a compost bin or pile. As these materials decay, they create nutrient-rich material to fertilize garden plants. So, composting, fertilizer. Corn can be processed into a fuel called ethanol. Many gas stations sell gasoline mixed with ethanol. Yeah, if you go to Costco and you buy gas, now there's a certain amount of ethanol automatically mixed into your gasoline. Composting is a great way to conserve resources in your backyard. New section, Alternative Fuels for Vehicles. Today, about 2/3 of all petroleum consumed in the United States is used for transportation. Developing and using alternative fuels for vehicles is a key to conserving petroleum. So, let's see, alternative fuels for vehicles. Our note is going to be key to conservation. Key to conservation. For example, scientists are developing engines that run on ethanol only. Even vegetable oils can be used to run car engines. I've seen that. I've seen people who collect old vegetable oil from places like McDonald's and Burger King, where they fry their French fries, and they clean that oil and they use it in diesel engines. Today, subways and many buses run on electricity. For an electric car, the challenge is to provide enough electricity from batteries. The batteries also need to be recharged, which may limit these cars to short trips only. Of course, today that's getting better. So, our note is going to be electric car, challenge, batteries. Electric car, challenge, batteries. Hybrid electric cars use both a small gasoline engine and electric motor that runs on batteries. In one model, the gasoline engine provides most of the power, but the electric motor adds power when the car accelerates. I actually had a car like that a long time ago. The electric motor just helped you go faster when you had to get on the freeway. The batteries recharge when the car slows down or idles. Another way to do it is to have it the other way around, where the battery power does most of the driving and the gas power is just there to give you a little extra oomph. Hydrogen fuel cells are yet another alternative power source. In these cells, hydrogen combines with oxygen from the air. This reaction releases a lot of energy. The only byproduct is water. So, our note is going to be hydrogen fuel cells, a lot of energy, only byproduct, water. Around the world, people have converted their diesel engines to run on used vegetable oil. Hydrogen fuel cells are used on spacecraft to power electric equipment. The astronauts even drink the water that the fuel cells produce. Okay, so they're able to get electricity from it and also get water that they need to drink. Pretty cool. Describe alternative fuels and their uses. Well, some alternative fuels include vegetable oil, or electricity, or even hydrogen fuel cells. And you can use those things to run diesel cars, or run cars on short trips, or supplement a car and give it a little extra power, or you can even get electricity from it and use the byproducts for other purposes. Okay, last section, renewable energy in California. Like much of the nation, California relies heavily on fossil fuels for its energy needs. About 42% of the state's electricity is generated by natural gas. Wow, that's a lot. Coal provides another 20%. In addition, Californians burn almost 80 million gallons of petroleum products each day. Okay, so under this section, we're going to say capital C, capital A for California relies heavily on fossil fuels. However, alternative energy sources also play a growing role in meeting the state's energy needs. In 2004, Hydroelectric Energy generated nearly 15% of California's electricity. Nuclear power was close behind, producing 13% of the state's electricity. Renewable energy sources such as solar, wind, and geothermal energy generated almost 11%. So, alternative energy play a growing role. Alternative energy play a growing role. The California Energy Commission sets standards for energy efficiency in the state. The Commission estimates that building and appliance standards alone will save $57 billion in energy costs by 2011. California also is promoting plug-in hybrid vehicles. These vehicles use larger batteries than traditional hybrids and therefore can travel longer distances in electric power rather than gas. Okay, so it's 2021, 10 years after this prediction, and really you only have like a handful of cars that can do that. But more cars are coming. The goal is to produce a hybrid that is pollution-free. So let's see. Promoting plug-in hybrids. Okay, name 2 ways California is conserving energy. Well, we're conserving energy by setting higher standards for energy efficiency. We're trying to come up with more alternative fuel cars, and we're changing our fuel from fossil fuels to renewable sources. Looking at this map, wind farms, you've got just a few. Those are in places where there's hills. And remember when we learned about weather, we learned about how the wind blows in between the canyons. Geothermal plants, there's only a couple around the state. Again, that has to be a very specific spot to get that hot spot of magma underneath to boil water. Hydroelectric plants, we have a lot of them, mostly dams, but remember that can hurt the fish ecosystems. And nuclear power plants, there's only 2 listed here. So we don't have very many.